welcome back to my channel. Yeah. So I am Aljimar from BSED Math J1. So for today's video, we have a new topic. Ang topic natin ay walang iba kundi ang Tcharan! Equivalence. So, if you want to learn about this topic, just keep on watching and don't forget to subscribe and hit the notification bell para updated ka sa aking panibagong video. So, if you are ready, just started to wait. Let me
Equivalence relation. An equivalence relation is a binary relation that is reflexive, symmetric, and transitive. The relation is equal to is the canonical example of an equivalence relation. Its equivalence relation provides a permutation of the underlying set in the disjoint equivalence classes. Properties. Equivalence relation are relations that have the following properties. They are reflexive, A is related to A. They are symmetric if A is related to B. Then B is related to A. They are transitive if A is related to B and B is related to C. Then A is related to C. Classes. An equivalence class is the name that we give to the subset of S, which includes all elements that are equivalent to each other. The equivalence class consists of the set of all X such that X equal to A. In other words, any items in the set that are equal belongs to a defined equivalence class. Intersection. The intersection of two equivalence relations is another equivalent relation. Suppose that n are equivalence relation on a set. Let denote the intersection of n tones of as subsets of x times s equivalently x equal y if n only if x equal y. Union. Equivalence relation. A relation R on a set A is said to be an equivalence relation if the relation is reflexive. Symmetric and transitive, consider two relations R1 and R2 on ZB such that A R1B equivalent to A minus B is divisible by 5 and A RB equivalent to A minus B is divisible by 7. Claim 1. R1 is an equivalence relation. What is an equivalence relation example? An equivalence relation is a relationship on a set generally denoted by a similar to that is reflexive, symmetric, and transitive for everything in the set. Example. The relation is equal to denoted equal is an equivalence relation on a set of real number. Since for any y, x, and z equal not R1. How do you determine equivalence relation? If 1 equal to G if 1, then G if 1 equals to if 1, so R is symmetric. If 1 equals to G if 1 and G if 1 equals to H if 1, then F if 1 equals to H if 1, so R is transitive. R is reflexive, symmetric, and transitive. Those R is an equivalence relations. Opening close parenthesis B, if one equals if one, so R is reflexive. Example number 1. Let's assume that f is a relation on the set R real numbers. Definitely x, f, y, if and only if x minus y is an integer. Prove that f is an equivalence relation on R. Solution. Reflexive. Consider x belong to R. Then x minus x is equal to 0, which is an integer. Therefore, x, f, x. Symmetric. Consider x and y belongs to R and x, f, y. Then, x minus y is an integer. Thus, y minus x equals minus in opening close parenthesis, x minus y minus x is also an integer. Therefore, y, f, x. Transitive. Consider x and y belongs to R, x, f, y, and y, f, z. Therefore, x minus y and y minus z are integers. According to the transitive property, opening close parenthesis, x minus y plus opening close parenthesis, y minus z, x minus z is also an integer. So that x, f, z, those R is an equivalence relations of R. Example number 2. Show that the relation R is an equivalence relation in the set A. Braces 1, 2, 3, 4, and 5. Given by the relations R equals brace opening close parenthesis A and B, A minus B is even. Solution. R equals braces opening close parenthesis A and B, A minus B is even, where A and B belongs to A. Reflexive property. With the given relation, A minus A equals 0 is always even. Therefore, opening close parenthesis A and A belongs to R. Hence, R is reflexive. Symmetric property. From the given relation, A minus B equals B minus A. We know that A minus B equals opening close parenthesis B minus A, 1 equals B minus A. We know that A minus B equals opening close parenthesis B minus A, 1 equals B minus A. Hence, A minus B is even. Then, B minus A is also even. Therefore, if opening close parenthesis A and B equals not R, then opening close parenthesis B and A belongs to A. Hence, R is symmetric. Transitive property. If A minus B is even, then opening close parenthesis A minus B is even. Similarly, if B minus C is even, then opening close parenthesis B minus C is also even. So A minus B and B minus C is even. Then A minus C is even. Therefore, if opening close parenthesis A and B equals not R and opening close parenthesis B and A equals not R, then A and C is also belongs to R. Hence, R is transitive. Example number 3. A relation R is defined on the set by A or B if A minus B is divisible by 5. For A, B is called not Z, examine if R is an equivalence relation on Z. Reflexive reflexive. Let A equal not Z, then A minus A is divisible by 5. Therefore, A holds for all A and Z, and R is reflexive. Symmetric. Let A and B equals not Z, and A or B hold. Then A minus B is divisible by 5, and therefore B minus E is divisible by 5. Thus, A or B implies B or A, and therefore R is symmetric. Transitive. Let A and B and C equals not Z, and A or B and B or C both hold. Then A minus B and B minus C are both divisible by 5. Therefore, A and C equals opening close parenthesis A minus B plus opening close parenthesis B minus C is divisible by 5. Thus, A or B and B or C, A or C, and therefore R is transitive. Since R is reflexive, symmetric, and transitive, so R is an equivalence relation on Z.